more and more writing like word. It's like.
It's pretty.
Oh, yeah, no, I know, it's just. What is the point? Oh, I'm sorry.
It's no elevation or pressure.
It's just so like. Didn't do anything.
Well, that's like the very last week.
That's the last Friday.
Yeah, this last like.
We have to.
No, that's the last, that's what I'm saying.
What is
I'm not
it?
going.
Good, like to the right.
Did they take the first one of the yesterday's? I know.
Okay, you finished the, you finished the day one this week. You finished day one.
No, I was really good.
Oh, you took the negatives. Okay, which one do you want to do? Day one or day five?
Yeah, 1 minute, let it at least sink in.
What is that? Day one days.
Day one is derivative, stage two.
Oh, the second one. Actually, the one that you took Thursday.
The first one, yes.
That's crazy. The second one.
Some laws. And we already did.
Still long.
I remember one, there's
And then,
natural law.
and then there's, this is kind of like-
No, because there's a natural law is the one.
I got 1 through 6. Yeah, 7 to 8 on the page.
There's nobody just, we just calculated the line.
Okay, we do the page.
Yeah, I get, cause I've worked on it.
We're just not very. We can get it from there.
I showed me a 95 on that. It's been insane. I thought it was super hard. The worst grade I ever got.
What did you get?
Sure, we'll have to check in.
It was a B.
Oh.
Checking quizzes, or is it just a test?
Just the test.
Yeah, that's right, you got a 15.
Oh,
That's a W.
but nice job. That's probably one of the hardest things to take in that class.
And the second to last.
Mine's in 34.
Okay, thanks. Okay, this is our final unit. Let me go over, the calendar here. We're not gonna have a whole lot of time to start 10.01, but we'll do what we can and we'll finish what we can't finish on Monday. And no quizzes for this unit. We're just gonna have a test. We're going to go over exponentials and see the relationship between logarithms and exponential functions. Okay, and then properties of logs. You've seen a lot of this from algebra 2, but logs are such a yes. For sure, yeah, you can do something. I'm thinking, do this 8 problems, you do 1 through 8, you're on 1 through 6. Really? Okay, so a lot of these properties with logs, solving logarithms. Gonna be an important part for calculus if you're taking calculus next year. Or just knowing the properties of logs and exponentials. So we're gonna spend a good chunk of time doing that. And then your test, will be the 19th. So that last day or that last week before the half days begin. So okay, any questions about the calendar? Okay, I realized that oh, and then also on the back of the calendar, you're gonna see a summary sheet, and we'll definitely use that summary sheet for as we look at all the properties. It's nice to have all the properties on one page. But if you go to the second to last page, page 31, I realized I printed this packet with last year's calendar. So if you can just put an X on that page and that you're not looking at this for your calendar. So the calendar is on a separate sheet that you usually picked up. So don't look at page. This is old calendar here. But it's still good to keep that page there because the last page is the summary sheet. So it's nice to have a summary sheet on the calendar as well as on the packet, in case you misplaced one. So that's once you look at the wrong calendar for our dates. Okay. Okay, so yeah. So let's have you guys copy down a couple of properties. These are properties that you should that you're probably familiar with, but it's good to just review. So product of powers. The idea here is that if I have multiple powers multiplied with another base that has different power, I'm going to be adding the exponents. Okay. So an example of this would be 2 to the third power times 2 to the fifth power. Okay. It's not going to be 2 to the 15th power. It's just going to be 2 to the 8th power. Right. The reason why is because if you think about it, it's 3 2s and 5 2s, and if you merge all that together, there's 8 2s, saving us 2 to the 8th power. So we're not going to multiply the exponents. We're going to add the exponents. Okay. Second one, quotient of powers. If I divide bases with different powers, I can subtract those exponents. Power of a product. If I have two terms that are raised to a power outside a set of parentheses, I can take that exponent and I can distribute it through, make it x to the n times y to the n. Now, something that we cannot do is this, right? If I have x plus y to the n, it's not quite as clean as just distributing that n through and putting a plus in between. It's more complicated than that. So anytime there's a plus or minus inside the parentheses, we have to remind ourselves that it's not as clean as and easy as we would like it to be. Now, if it was multiplication, then that's fine. You can distribute the exponent and you're not breaking any rules. But here, it's only giving you a partial instance of what that problem is. And I just want to give you a quick example here. So let's say I had x plus 2 raised to the second power. It's not as easy as just saying x squared plus 2 squared. Okay. There's more to it than that. If I fold it out, there's actually I got an x squared plus 4x plus 4. So this is something an easy trap to fall under because it feels like it makes so much sense for us to just distribute through. Okay. Power of a quotient. If I'm dividing and I have an exponent outside, I can distribute that exponent through and no issues there. Power of a power. So if I have two exponents next to each other, then I can multiply those exponents. But if the exponents are separated by two different bases, then I have to add those exponents, assuming the bases are the same. Okay, negative exponents. If I have a negative exponent, I can force that negative exponent to be a positive exponent if I push that base down to the denominator. So for instance, x to the -2 is the same thing as what? Yeah, 1/x². Right, that's a way for us to move exponents in the numerator and denominator. Zero exponent. It's a oh, this is a broad property here. Basically, anything that is raised to the 0 power is going to be 1. Okay, not 0. Anything raised to 0 power is 1. And then rational exponents. So if I have something, a base raised to a fraction, I can break that into a radical form, and I can say the nth root of x to the nth power. So for instance, x to the 4/3 is the cube root of x to the 4th. Let me give you some more examples here. What's x to the 1/2 equal to? In terms of radical form. Okay. And typically, we just leave that, we don't put a number here, even though it's technically anything square root is really understood hidden 2 here. And also, we don't put a 1 here either. We could do 1 and 2, but typically square root of x is just x to the 1/2. Let me ask you guys to go back in the other direction here. What if it was the 7th root of x²? How would you write that in exponent form? X to the 2/7. Let me give you the one that most students struggle with. Well, not most, but a lot of students struggle with this one here. What's that one? X to the 5/2. It doesn't seem that hard, but what do you think a lot of students want to think of this as? Or 1/5 or 2/5, but that's not right. Okay. I think this is the most common one. Students feel like, oh, there's nothing here, so that must be a 1. They do 1/5, but it's actually 5/2. So yeah. So that causes a lot of issues in terms of mistaking what that actually is. Okay, so number 1, we're going to use properties to simplify, and we're going to answer we'll give our answers with positive exponents. So this, what we can do is we can distribute the 4 through, distribute the exponent 3 through. Now the 3 is going to affect what? Yeah, good. The A, the B, and the 4. Okay. So there's a hidden exponent there with 4. It's 4 to the 1st power. So if we put a 1 there, I think that's really helpful in helping us see what is going to happen with that 3. So what does that become? 4 to the what? 3rd power. Okay. Followed by, good, multiply. And then B to the -6. Okay. And if I want to present my answers with only positive exponents,
1/6.
yeah, well, I can just put that B in the denominator
Oh,
and make
okay.
it B to the 6th power. I just put this on a separate sheet to show my work a little bit more easily.
You don't simplify like the exponent.
Oh, you mean like canceling out?
Yes, like you don't make it like 64, like A to the 3 and B like this one. You just keep it like A to the 9 power and B to 6.
Right. Yeah, as opposed to what? As opposed
So
to
like A to the 3rd power and B to the 1st power, like these subtraction.
oh, you mean reducing these
Yeah.
fractions? You could if the A's and B's are the same basis, but they're different bases, so we can't just take the exponents out. But if I had a to the 9th over a to the 6th, then I can, sorry. If I have a to the 9th over a to the 6th, I can subtract the exponents and I can make it a to the 3rd, because 9 minus 6 is 3.
So it'd be the same.
You have to be the same base, yeah, same base. Or another way to think about this is if you have 9 A's and 6 A's, if you cancel all of them out, you're left with 3 A's left. Okay, let's look at number 2. If I want to clean that up, what happens with the parentheses, or what can I do with the exponent there? X to the 9th, yep, 3. And then once I have that x to the 9th, is there anything else I can do? Yes, is there, okay, if I do that, there's also something else I can do. Is there anything I can do with the x to the 9th and x to the -1?
X to 8.
8, yeah, because 9 minus 1 is 8. But it's the same thing, right? If you put that x in the denominator, you can still cancel it out and convince yourself it's going to be x to the 8th.
My answer would be 2x to 8.
Yeah, 2x to the 8, yeah. Okay. Next, number 3, try this one. Clean up the exponent, clean up the parentheses, and we want to let our answer display all positive exponents. Okay. What happens after I distribute the 3 through? Yep, x to the -6 over y to the 12th. Yep. And then how can I resolve that negative exponent? I could just move that x, right? Where can I move this x? Denominator. Once it moves, then the exponent turns what? Positive. Okay. What's left up top? 1. Good. Still a 1 left up top. A to the 4th b squared over a to the 1st b to the 5th. Think of this as, you know, you're writing all the individual a's out, a times a times a times a, and then you have all the b's split up by multiplication, and you can just kind of think that as canceling each other out. Right? Whichever side has the higher exponent is going to be the variable left standing in that numerator or denominator. So if I have 4 a's above and 1 a below, what's going to be left? A to the 3rd in the numerator, right? So if I have 2 b's up top and 5 b's below, what's going to be left over if I were to reduce everything? B to the 3rd in the denominator. Okay. Yeah, what I did was I just subtracted exponents. I did 2 minus 5, which is -3, and then I brought the b down. So there's a lot of different ways that you can reduce as long as you're following appropriate rules. You know, you could potentially have countless ways of reducing to the answer or to the simplest form. Okay, try number 5. Okay, what's gonna happen in the denominator once we handle the outside exponent? Well, in the denominator, what's gonna happen with the denominator? What does it come?
The zero power becomes one.
Good. Right. This whole thing becomes one. But one squared is still one, right? Okay, so, yeah, so the only thing left in the denominator is just a 4. And that z is a 0 exactly as 1, and I can drop the z because it just turns into 1. Z over 4 is as far as I can go. Try number 6. What do I do with that 3 outside? Okay, so if I distribute that 3 through, what do I get? 3 to the, oh, yeah, so we're gonna multiply these. Okay, so 3 to the 12x, and the bottom we get what? 3 to the 6x.
When we get distributed to the previous.
It only touches the exponent. And we're gonna multiply. What do we do from here? Yeah, I can subtract, right? So if I have a base, the same base, and numerator denominator raised to different exponents, I can just subtract those exponents and just make it all come to the top. So what's 12x minus 6x? 6x. Okay, let's do 1 or 2 more, and we'll be done. So number 7. What can I do with 2 to the negative 5 power?
New denominator.
So if I move that to the denominator, what's up top? 1. Okay, so it's 1 over 2 to the 5th. Anyone know what 2 to the 5th is equal to? 32. 1 over 32. Okay, what's 36 to the 1/2? What does that mean?
6.
Square root of 36. Yeah, and the principal value is just positive. It's not plus or minus 6, just 6. Okay, last one here. 27 to the 4/3. Anyone know what that looks like as a radical form?
It's cube root of 27 to the 4th power.
Cube root of 27 to the 4. Now, this feels like a complicated thing to do, but we can actually pick the order that to make it easier to do. Cube root of 27 is more manageable than trying to do 27 to the 4th power. What's cube root of 27? Then we can do 3 to the 4th power, which is 81. Yeah, 9 times 1 is 80. Okay, we'll continue with these pages on Monday. Okay, can we get the phones? Same base, you can drop it out. This one, you want to force the same base to.
Oh, so is it like coming up?
Yeah, so you know 9 is 3 squares, so if I replace this, then I can.
Enter them and.
Distribute, yeah.